So we are solving radical equations both graphically and algebraically today. One of the things I want us to remember, oh, my pen is dying. Okay, let me just shake the battery for a second. When we are solving for radicals or solving radical equations, what we are doing is we are finding the x values that make y 0. Okay, so this word solving means finding, spelling not my strong suit, finding x values that make y equals f of x 0. Okay, some words that you should already have heard at once upon a time in your life. These represent the x-intercepts, or the roots of the equation, or the solutions to a given equation. What's another word I can use? Zeros, finding the zeros of the graph or the equation. All of these things mean the same. We are looking for what x values can we put into our equation so that when we solve it, our solution is 0. Okay, so when we are doing this mathematically or algebraically, there's a 4-step process. Step number 1 is list any restrictions that you have. Now we're going to deal with pretty simple equations today. So the restrictions are whatever makes sure the radicand, whatever is inside of the radical has to be greater than or equal to 0. The next step is to isolate the radical and square both sides. So we want something that looks like this. Radical equals stuff on the other side of the equation. And this is where a lot of people get tripped up. When we square both sides of the equation, we are not squaring the individual pieces. We are putting giant brackets around the left and squaring it, giant brackets around the right side and squaring it. Okay, I don't want you to write this part down, but I want to do a little demonstration. I have seen students do something like this. Let's say this is my equation and I'm solving for x. And the student will say, okay, x equals y squared minus 2 squared. They've squared the individual pieces, which means their final answer will be that x equals y squared minus 4. Do not do that. We are saying that everything on the left represents everything on the right. So when we square it, we are squaring the entire function or the entire equation on the right side. This means that x equals y minus 2 times y minus 2. This is essentially a perfect square, right? So this is y squared minus 4y plus 4. Notice that this is not the same thing as y squared minus 4 as we got up here. So this is wrong. Do not do that. We are squaring everything on both sides of the equation. So first get the radical by itself and then square everything. The last step is find the roots of the equation. This means essentially solve for the values of x. And the last step is that we have to check our solution. It feels silly to check the solution because if we've done the math correctly, then the answer we get should be correct. However, context matters here. So we are going to be looking for extraneous roots. That means anything that does not satisfy the original equation or the restrictions. Sometimes we'll find answers that fit the restrictions, but they don't solve the equation. or they solve the equation, but they don't fit the restrictions. So we're going to have to check for both ends. Okay, the way that we check, here's just a quick example. If I have this equation here, 7 equals root 12 minus x plus 4. Here's my restriction. Looking at the radical there, I have a 12 minus x, so I need an x that is less than or equal to 12. And you can see minusing 4 from both sides gives me this step. I'm squaring everything on both sides, and I'm solving for x, and I get that x equals 3. The first thing I do is check, does it fit the restriction? Yes, it does. The next thing I'm going to check is I'm going to take what I got, x equals 3. I'm going to take my original equation, I'm going to substitute the number that I got. The important part here is I draw a line down the middle of my equal sign. When we are checking, we are not moving things left and right across the equal sign. We solve the left side, which is just the number 7, so I don't touch it. And then we solve the right side, and you can see here the steps. 12 minus 3 is 9, square root of 9 is 3, 3 plus 4 is 7. And if both sides agree, then we have a valid solution. So it must respect the restrictions, and it must give us the same answer on both sides of the equation when we do it mathematically or algebraically. So this is a valid solution. Another way we can do this is by using a graph, and there's two methods to use with the graph. In an example where we have a two-part equation, meaning we have something, something, something equals something else. In order to find what is the solution here, method 1 is called the single equation method. And all it's saying is move everything to one side and have 0 on one side and all the equation stuff on the other side. And then use a graphing tool such as Desmos to find the solution. So here, I'm going to go switch over to Desmos. You can just watch me on your screen there. And I'm going to, oh, I see that this is hide. There we go. I'm going to type in the equation square root x plus 4. And I have to step sideways to get out of the radical, minus x minus 4. And Desmos is a really great tool because if you zoom in, it will highlight the key points of interception here. So what we are looking for is an x-intercept. What makes it 0? And if you kind of hover on here, it'll show you what the key points are. So the 3 key points it's showing you is the starting point, the maximum point, and the x-intercept. So if I hover on here, you can see the answer here, the solution, the x-intercept, the root, the 0, whatever you want to call it, is -3, 0. I know I've included a picture here as well. All right, so my solution is that the value -3 is going to give me a y value of 0. Method 1 requires a little bit of math because you have to take stuff from the left and move it over to the right or vice versa. In method 2, it is graphing two equations. Rather than shifting things around, let's leave the equal sign in the middle. Let's use the left side as y1, and let's use the right side as y2. Now here, because I have two equations equaling each other, what I'm looking for is an intersection point. Where is the crossover? Or where is the intersection? So now I'm going to backspace here. This is going to be the square root x plus 4 plus 2. That's my y1. And then I enter a second line and I do the other side of the equation, x plus 6. And again, with Desmos, it will highlight to you the key points. The point of intersection here is -3, 3. So when I go back here, no matter which method I use, I should get that x is -3. Now, if you do the 2 equation way of doing this, because we're looking at an intersection point, you'll notice that the y value here isn't 0. That's because when we're graphing 2 equations, the crossover is no longer an x-intercept. It's only an x-intercept if I only have one equation that I'm solving for. All right, let's do an actual work through example here where we get to practice our skills. Okay, we're going to go through the 4 steps. Consider the equation 2 root x minus 4 minus 3 equals 0. So first step is I need to identify my restriction. What's my restriction here? So yes, x must be equal to or greater than 4. This is the restriction I'm working with. Now I'm going to go through the steps of solving the equation. I want to isolate for x, so I'm using the steps of BEDMAS backwards. First, I get rid of that 3, right? I'm going to add 3 to both sides. This gives me 2x minus 4 equals positive 3. What's my next step? Divide the 2. Yeah, divide the 2 on both sides. I get that the square root of x minus 4 equals 3 over 2. Okay, now my radical is by itself. So the next step is to square everything, right? Big brackets on everything. The square and the radical cancel, leaving me with x minus 4. And on the other side, what do I have? Square the fraction. What's the top? 3 squared is 9, and 2 squared is 4. Okay, and then my last step here is x equals 9 over 4 plus 4. How do we add fractions? What's the rule? Common denominator. If I have a number that doesn't have a denominator, what could I put in its place? A 1. What's my common denominator between 1 and 4? 4. So let's multiply top and bottom by 4. So this is that x equals 9 plus 16 all over 4. And my final answer is 25 over 4. So I have an answer. The first thing I'm going to do is, does it follow my restriction? Sometimes Ms. Gordon isn't good at math, so I'm going to stick this into my calculator. 25 divided by 4 is going to be 6 point something. Is 6 point something greater than 4? Yes, it is. So I can accept this. It passes my first check. It fits my restriction. The next thing I'm going to do is check it mathematically. I'm going to put 25 over 4 in place of x. 2 square root 25 over 4, and I leave everything the same. I draw a line. I'm not going to move anything over to the other side. I'm just going to maintain 0. Common denominator again, right? I need to put this over 1 times 4 times 4. This is going to be 2 square root 25 minus 16 all over 4 minus 3. 25 minus 16, what am I left with? 9, thank you. 9 over 4 minus 3. Okay, square root of 9 is 3. Square root of 4 is 2 minus 3. Then I can cross reduce there. I'm left with 3 minus 3. Does that equal 0? Yes, it does. My second check is complete. So I can write now my conclusion. Okay, the solution is 25 over 4, or you can write 6.25 if you want to write it in decimal form. Either way is fine with me. Okay, so when I graph the function, I've included a picture here. I've done it for you already. You can see that it crosses over at 6.25, which is what we expect it to do. I used the one equation method because all of the numbers in my function are on the right side, and I've got nothing on the other side. So I'm just looking for where is y 0. Okay, so another way of saying this is the x-intercept. The root or the 0 is the x-intercept. Okay, I'm going to let you have a try at this. Here's our second example. Determine what is the restriction first. Do this algebraically and tell me your answer. Now remember, it is possible to have more than one possible answers, which is fine, but we're going to need to check those answers. So once you find your 2 answers, go through the second half of the page and do your check. Okay, so I'm going to pause here and give you some time to try this out.